Okay, so up to the last session of the semester. It's always exciting reaching the end. It looks like everybody in the class has been doing really well. Just a couple reminders here. Well, tonight's going to be kind of a short session. Nobody reached out to me with any questions in particular, so there was one last thing I thought I'd go ahead and talk about for a moment. But just a couple quick reminders. Everything is due by Saturday at 11:59 p.m. That's when that's when all the paperwork says the semester ends. So that's when all the assignments will close and lock. And first thing Sunday morning, I will get up, finish any grading, and submit grades. So they will probably be turned in by like 8 o'clock on Sunday morning. I'm old. I wake up early in the mornings. The world seems much more peaceful at 5 a.m. when everybody's asleep. So yeah, that's coming up soon. I will send out a reminder and announcement as Saturday draws closer. Just one more reminder about it. Also, I wanted to say, please fill out the evaluation forms on Ivy Learn. It shouldn't take too long. I have not seen the ones on Ivy Learn. I don't have access to them. But I remember before going digital, when those were done on paper, it was just like 10 or 15 questions. It never took more than 15 minutes. And so it shouldn't take too long to do that. Oh, there's Tom. Bring him in. Hello, Tom. We were just getting started. Like I said, I just mentioned a reminder that everything is due Saturday at 11:59 p.m. That's when all the assignments will close and lock. And yeah, so nobody reached out to me with any questions in particular. So I had something in mind that I wanted to kind of. Oh, yeah.
Sorry, I do have one question. Is it over the final paper? I'm kind of confused on. Did you want us to like basically hit print parentheses, quotation marks, and then type out a paper and then have it print out that paper? Is that correct?
Yes. And okay. save important parts. So like the like names and dates and things. Save those in variables and just kind of but basically just put an essay into print statements.
Got it. And the variables that we're saving are, I imagine you want them to be like
things that would show up occasionally, or just to kind of include that in the process. Kind of like the word Python is going to show up there quite a bit.
Yeah.
You can save that to a variable called pi or something.
Got it. Okay, I see. That's what you're saying. I see. So like you'd in parentheses, comma, put the variable, comma, restart, not parentheses, sorry, quotations, comma, the variable, comma, quotations, and then continue with the paper, right?
Yeah. A bunch of concatenation. And so kind of like that very first introduction discussion board we did was where you save some facts about yourself in variables, just some facts about the Python programming language, store those.
Got it. Okay, just making sure, because I was like, I didn't know if I was just supposed to type the whole paper into a print statement, and then I was just like, okay, I felt too easy, right? So I had to make sure, but okay.
Yeah, most of it will be. In other classes where there's a lot more interface stuff going on, graphic interface stuff, like the website development class, or any of the 200 level programming classes, I include formatting on that as well. So like a similar assignment, but it involves formatting it to look like the stuff. But yes, for this class, basically just everything in print statements, put an essay into print statements instead of a Word document.
Okay, and then just send in the Python file. Got it. Okay, cool. Works for me.
Yep. Any other questions?
No, that's the only one that I had. The rest of it's kind of self-explanatory.
Okay. Yeah.
So actually, I do. Sorry, one last statement. Because I know you can only take the final once. is there like a practice quiz type thing or study guide we can look over? Because like I know we can't look over. I tried looking at the old quizzes, trying to see if I could see the old answers I put up there and study from those, but they're closed out. So I didn't know if there's like a guide I could follow or not follow, but someone.
There's not a guide, but if you do really terrible on it, let me know. I can open it back up. But it
Okay.
should be it should be kind of like the midterm was, where there's some from the old quizzes,
Mhm.
but it's mostly the current content.
Oh, is
It's
it
almost
okay?
like half of the exam is what would be this week's quiz.
Okay, cool. I just want to make sure because I didn't know if what I should study over or what I kind of just was like, you know, just kind of looking over a bunch of it just to make sure. Just kind of was looking at like discussion boards and stuff like that, saying like, and then like old assignments and just kind of going off that. So
Okay, it'll be a lot like the midterm.
okay,
Remember what I'm talking about there, where it was almost like that week's quiz was
yeah,
half of it, and then a few bits and pieces from earlier in the semester.
got it.
So it'll be like that for the second half of stuff from the second half of the semester.
Okay.
And I think it is like 2 hour time limit, right?
I don't remember if I'm being honest.
I believe there's plenty of time to look stuff up
Okay,
and
cool.
double check things. Be careful with second guessing things.
Yeah,
But there should be plenty of time to look stuff up. And if something happens, just let me know.
will
Like
do.
if yeah, I'm pretty laid back. I know how it goes sometimes with quizzes, but it should be very straightforward. And otherwise, if you did okay on the previous quizzes, it'll be very similar to those, and there might be some information from that, and otherwise, it's basically like the content from this week.
Got it. Okay. Thank you.
Anything else?
I believe that's all. That's all for me, anyways.
Okay, so it's going to be another short night. Nobody reached out with any particular questions. So there was one point I wanted to kind of readdress, something we went over earlier in the semester, related to what you just asked, Tom, about the file writing. Because when we went over that section, I think it was week 5, when we did the basic file in out, there was just a couple little things like write to a text file, read from a text file. We didn't really go in depth or make a big deal out of it. But, well, the label on this class is Introduction to Software Development. And when we're making a big piece of software, that writing files tends to be a big deal, a huge chunk of it. Like on some things I've developed, it seems like dealing with files and folders is half of the code. Well, for one, if we're making a piece of software, we're doing that for a reason, so we probably want the data to stick around in a usable format. And it's good to keep things organized and have workspaces and things like that. So it often ends up being kind of a big deal. Something everybody's probably encountered before when computers crash or something, power goes out and you're in the middle of maybe writing a Word document. There's like the auto recovery feature. Right? If you haven't saved in a while, there's probably something in the auto recovery. It might not be up to the last word you typed, but stuff like that. We want to keep things like that, related files going. So I wanted to take a quick look at a couple of those features in Python. So stepping back to Python language this evening, because that's a little easier. And conceptually, it'd be the same for to work with Visual Basic. It's just Net32 has a whole lot of extra steps involved for writing files and stuff. It's easier to do in Python. So I figured we'd talk about the concepts in Python. But just kind of a step further on that file in out stuff. So I'm going to go ahead and share my screen and open up idle. Yeah, there's not really much to write on the board with this. It's working with files and folders, which is what we do all the time in computers anyway. So I just wanted to kind of express this point because we barely touched on it. And when actually developing a large piece of software, writing files and making folders for those files to go in turns into kind of a big deal. a lot more than what it seemed like when we have just like short examples where we read from one file and open it. Often we'll have lots and lots of files involved in the project. Make that smaller so the whole thing fits on my screen. There we go. So there's a built-in package that I'm going to import some stuff from. Actually two. I'll go ahead and do the whole list. So from OS, I'm going to import some stuff. And from os.path, I'm going to import some stuff. So you can see both of them. OS stands for the operating system. So that's built to work with whatever operating system you're on. It'll just go with whatever system the stuff's running on. I think I'll go ahead and just list out all the imports I wanted to talk about. So one from OS called make dirs, make directories, and along with which is just creating a folder. We saw creating a file, which isn't any. It worked fine when we put that file in the same place our program was. But a lot of times when we install software, we put a piece of software into, well, on a Windows machine, I'll open up the folder. When we install software, we usually install it on the C drive in either this folder called program files or this folder called program files 86, x86, one of those two folders, and we install stuff there because there's no write access. Anything in those folders only has read access. So that means when we install software and save it there, it's not going to actually get changed. It's not going to get messed up. It can't be changed once it's in that folder, which also causes a problem for, like, say, writing a text file, because then we can't write a file into the same folder where our application is stored at, or where our actual program is stored at. So we need a way to make the folders that we need. There's also make dir singular, and that will make one folder at a time. If we add the S on the end, we just pass in like a file path, the whole directory structure we want, and it will make every folder along the way that doesn't already exist. So even if I only need one, I tend to use the one with the S. And similar things are available in every programming language, but a way to make a folder to put something. And then a very useful one is we might want to know what's in a folder. So we also have this thing list dir, which is just a list of everything in that folder. And yeah, we'll talk about some stuff to do with that. I might add one more on the list. For now, I'm going to start with files and folders. There's another one that I put on my notes today, but I'm not sure if I'm going to include that just yet or not. And then from this other one, os.path, which if you haven't seen this before, this is like in a directory structure where we usually write out all the folders and separate them with slashes, forward slashes or backslashes, whichever one we're using for the system. When we put that in our import statement, that's the same as a slash. So this is this os.path. That's like wherever my version of Python's installed. I'll just write ... Wherever Python is installed, inside of that, I guess probably inside the library, there's a folder called OS, and then inside of that, there's a folder called path. So whenever you see a dot in the import statement, that's just saying a subdirectory. So from os.path, a couple really useful ones, which the first two, the names kind of give it away, is file and is directory. Just something to throw in an if statement to get true or false back, to know whether the thing we're looking at is a file or a folder. And we also have this thing join. I'll go ahead and talk about that. It's a very useful function. Personally, I prefer to just type out the directory names, but it's I'll go ahead and mention that one as well. So most of them from the names, you can kind of tell what they're doing. So I'm going to create a function to run this stuff. Define a function called, I don't know, example. Not really thinking of a name, and I'm going to pass in a path every time I run this. So like, it'll be a file, a folder to a path. So maybe the first thing is we can just check this path to see if what we're looking at is a file or is it a directory. So let's see. Maybe I'll go to where Python's installed here and look at some stuff in the Python folder. I'll grab some directories from there. There it is. I probably could have picked something a little closer to the top. There's going to be a lot of typing here. Yeah, so in here, the Python library, there's some you can see are files, and some are just folders. So I'll just use that as the path to refer to that. So I'm going to copy that, and I'm going to put it over here, comment it out, because as you'll notice, there's kind of a problem with that. Copying that on a Windows machine, it put all these backslashes in. But in Python, backslash is an escape sequence. So I need to go through here and add in a second backslash so that we can actually say, put a backslash in that spot. It seems a little bit awkward. Most programming languages will automatically change those, right? In a Linux system, Unix system, we use the /, which we could just type directly. And a lot of times in Windows, we can type the / and it'll translate it. So that's a good way to type it. I've just found over the years, especially if I'm on a Windows machine, well, most programming languages will alternate it to whatever it needs to be for the system it's running on. And I've personally found that using the two backslashes, it can be easier to spot. It makes them easier to see than just a single slash. So I've kind of gotten in the habit of using that. So that'll be a path we can look for, and then we can kind of check these things. So like, is file, is directory, like the name implies, that's checking something specifically. So like, if is file, whatever the path we put in is, print, it's a file. Obviously, in real situations, do something more interesting than print there. I just wanted to kind of look at the idea of this, a way to check and see if we have a file or a directory. Because usually it's one or the other, right? We only have those two types of things where we store stuff. It's either the file where we actually wrote the data, or it's a folder holding a bunch of things from that data. So if it's not a file, then it has to be a directory. Then I'll run this. And I saw this show up in a couple people's homework. The book doesn't really mention it. When we want to run this thing explicitly from this class, we can just say example and then pass in our path name, right? Which I got those things added in. So I'm going to call that path equals that. So we could just pass this in, but that can cause a problem because it's going to run through here. It's going to store that stuff in the variable, set up the function, get everything ready to call that method. And then it gets here and actually calls that method. But if we import this module into something else to use it, it will do the same thing. It will go through there and read all this and then finally get down here. So in some examples you might have seen, I saw it show up in a couple people's homework. Something we can often check is this condition right here. If name with 2 underscores before it and after it, because it's one of the core things. So name is what Python calls our program on the inside. Whenever we run things, because often we'll have a whole bunch of different scripts, right? Like this one right here involves the OS folder, 2 different modules pulled out of the OS, Python files pulled out of the OS module, the OS/path folder, and 3 different files, Python files pulled out of that. So it's going to rename all that stuff as it pulls them in. And one we can check is the thing we actually hit the run button on, it will name that main with 2 underscores before and after it. So in general, it's considered good form to make that check. If the name of the file, what the Python interpreter knows it by, is main, then that means that's the thing we actually hit the run button on. So then we can put the run stuff, like run our main loop or our main method, inside of that condition. It periodically shows up in homework. It periodically showed up in homework this semester. Just assume came from example somewhere. I don't think we talked about that. I never put it on any of the notes, so might have mentioned that. But this is an alternative for when we want to run stuff. I thought I'd mention that because, I don't know if some of y'all will see Python, have Python show up in other classes or not, but it's a very common language to work with, very easy language to work with. So there's a good chance that when you need to write a small script, no matter what you're doing, if you're an administrator for a network, or just a doing general IT service in an office, there's a chance you might want to automate some stuff periodically. And Python is definitely the easiest way to automate it. It's definitely good for the program. Everything about Python is to make it easier for the programmer. So that's just a way to make sure that before we just run this method, make sure this is the file we hit run on. So I'm going to save that somewhere, probably over in the delete folder. I'll just call it example. I'm not feeling very creative with names this evening. But when I run this, it'll look through there and check that path, which obviously that went to the library. So that should tell us it's a folder. We go ahead and run it. Oh, got a syntax error. Oh, whoops. That was just a silly mistake on my part. A directory, a file path, directory path does have to be a string. So always make sure those are strings. Now, if we try running that again in F5, there we go. It tells us that's a folder, which means we got a false for the is directory. Where's something in that folder? We could check something down here like /CGI. I just looked on here and saw there's a module in here called CGI.py, one of the core libraries that came with it. So path plus a couple more slashes, then CGI.py. And if we check this one, tells us it's a file. So just a quick way to check and see whether you're looking at a file or a folder. And is directory would go the other way, because it's either a directory or a file. Usually we check one, and obviously if it's not that one, then the other one, the else part of the if block, has to be the other one. So if I run this, same results we just saw. Yeah, the main point of this isn't the print statement there. Obviously, if it is a directory, you could probably, if you're using that, you probably have much more interesting things to do if it is a directory than just print out some words. Or if I take this off, it should be tell us that it's a folder. Same thing we just saw. Nothing too fancy in the output, but a simple thing to check. And notice that it is a method that returns true or false. So we don't need any comparison there, because the result after that method runs, it's going to return either true or false. And so we can put it right in our if statement. So that's the first thing. I'm going to comment that out and look at the next one. Another very useful one, I'll look at this list directory. Well, actually, real quick, why don't I go ahead and do that other thing from that os.path module. Sorry, I'm going to uncomment this, and this one, join. What that does is put two things together. So a moment ago, I typed plus a couple more slashes. I think it was cgi.py, just to check and see if that's there. So if we run that, we can see it's a file. I'm going to add another print statement in here. Print so path. I'll go ahead and print the path. And what I usually do, there's a couple different ways to do it. I'll write what I usually do, which is sort of the manual way, is we know that when we get to the file name, is that showing here? Yeah, so like here, the very last thing, there's that last slash, and then the thing we're actually looking at, right? Or in this case, we added on the last slash and then the file we actually want. So a lot of times I'll do path and then read it from path.rIndex. You'll remember that from the string section, the right index. So looking for the very last occurrence of a slash. And then we'll read from there to the end. So that'll give us just the file name. There's a shorter way to do it. I probably should have included that on the list. This time it'll print that it's a file and the name of the file. Oh, whoops. I think I meant to do +1, because you see we still got that backslash. Remember, the start is included. So probably that +1. But the other one I was going to show was this. There's another method in here called base name, which would do the same thing as this. So instead of that singling it out, that's the way I'll usually do it, which I think is just out of habit. We can also do base name of path, and that'll give us the very last thing. Run that. Can I import base name from? Oh, whoops. Base name, there's an E in there. Let me try that again. There we go. So you can see that's the quickest, easiest way to pull the file name off the end of a very long directory. And surely there's something built in to split up like the file name and the extension. It's only a couple lines to actually split that up in a string, right? We can just take call the dot split method and split it on a dot. Because once we have the file name, we know there's going to be only one dot there. So if we split it on the dot, then we have the name and the extension. Probably years ago, I wrote a method that did that. It's only only takes 3 or 4 lines to do that. And I've just copied and pasted and never got around to checking if there's actually one built into the language. But it doesn't take much to just split it up from that. The base name will give us that. And this other one here on the path in the path folder is a join. And that does this right here. So instead of concatenating those together, we can just pass them in as 2 arguments to the join method. So I want to join path this path variable, or whatever stored in this path variable, with the string, which is a file name cgi.py. And I think I named it a parenthesis. So that does the same thing, only better. Much more efficient than manually typing those slashes. It'll keep track of everything. And yeah, it's generally a better way to do it because then it does it for what the system you're on is. And then obviously we could nest that, like we could nest join functions inside of join functions to build up a big long path like what we have here. But I just wanted to mention this because we just looked at some basic reading and writing files. It didn't really talk about where to put them. So this, so you can see it does the same thing. It just concatenated those together much more efficiently than string concatenation does. We'll comment those out. Whoops. Not that button, that one. And this other one, list directory. Yeah, why don't I do that? Actually, instead of commenting that out, I'll put that here. If it is a folder, then call list directory on it. With path, and probably set that. Well, I'll just print that. Obviously, in most situations, you'd probably want to save that to a variable, you know, like p equals list directory path, and then walk through it in a for loop for something in that thing. But this will give us all the folders. Will tell us everything in the path, basically, everything in that directory. So if I run this, oh, whoops, not run that yet. Still looking at the file. So I'm going to undo the join one. And this is why I often do the concatenation, because I tend to do a lot of copy and paste when I put scripts together. And I find it easier to delete the copy and paste part than to delete this whole method part. Because all the concatenation was at the end, so I could just start there and delete stuff back and don't accidentally forget a parenthesis or something if I need to delete it. So this time I'm going to pass in this directory structure, which is heading towards the library where Python is. So it is heading to another directory. So when it prints it, it's going to print the results of this list directory method. This is a very, very useful one. It's telling, basically, yeah, you can see list out every file in there, all the py stuff. And then here, well, it's all Python stuff, so it's either a .py file or a folder. We can check that. I guess we could organize it nicely. I started to mention that. So might as well do this. That does return a list. So I don't know, I'll call it path list equals that. And then we can just walk right through it. So like for item in path list, should look like something we saw before with Python. Is directory, if that item is a directory, and I already cleared those results. This is like calling base name. So whenever we do this, it's a list of all this base name stuff. So we only have that last thing. So if we want to check if that is an actual directory, it's going to tell us no unless we have that whole structure to it. So path plus that whatever that last item is. If that's a directory, then print I don't know, folder plus item. If it's not a directory, it has to be a file. So whoops, I missed an I. Color changing is nice sometimes. It gives us a quick and easy way to see if things are, if typos made it in there. Otherwise, type file plus whatever the item is. And yeah, get just sort of a description of what's in there. Because obviously, if we're looking for a particular file to read, we could just ignore anything that's a folder and then just check those items until we find the file we want, and then only deal with that one. Kind of narrow things down quickly. So that's kind of a long list. The print statement obviously took the longest time, but you can see it gives us everything very quickly gives us everything in that directory and tells us, well, in this case, just print it out whether it's a file or a folder, but I feel confident you'll have enough creativity to do more interesting things than a print statement at this point. If the logic there and that selection structure makes sense. It gives us a way to look at stuff. And like I was saying, a lot of times in software development, we're creating that piece of software because we want, for a reason, which means we probably want the data to stick around and be safe. So things like autosave in the background, right? Go ahead and set a timer in the program, import time, and then the time every 300 seconds or something, automatically save everything to a temporary file. And whenever the user manually hits save or Control S or whatever that software needs to do to normally save, we delete that temporary file. And then whenever the application starts up, just check to see if there's a temporary file there. And if there is, throw up a message to be like, oh, there was something left in auto recovery. I think you all have seen those messages before, right? It's not a complicated thing to put together, and it's very, very useful because it protects our data. We don't lose it. And these are the sort of things we need to do that. The last one here, for make directories, I'll just do a quick example. Well, what we saw in class with the open file handlers, open test1.txt, and write mode as toFile, toFile.write, some words. That's kind of what we saw in class, right? I think our textbook uses the other one. I'm pretty sure I showed this in lecture. This is the way I prefer it. It feels more like standard Python syntax than just throwing the module, is where you have that keyword followed by the parameters to make that keyword run, and then the semicolon at the end. Just like what the text does, it's the same open method. I believe the textbook would have done that as something, since it's been a while since we've seen it, the same statement would have been toFile equals open, all that stuff in there. Oh, that gets out of the way. So the same thing here. I just kind of prefer this method. This is the syntax I'm used to using. But this is what we saw. So if I run this, so you can go through there. I probably could have stuck an echo or something to confirm that it was worked. But over in the delete file now, delete folder, I have this little text document. Nothing too special there. But adding folders in could be a problem. Going one way is okay. Like if I wanted to add a folder into the, well, let's just look at what happens. If I wanted to add a folder into that same, to put this into, I'll just call it fold, add a couple slashes, and send it in this way. If I hit run, get this error. So it had no trouble putting that in the same directory. When I asked it to put it in another directory, it wasn't very happy with it at all. So that's where we could use some of these things and see if that directory exists before working with it. So like, if is directory, well, from where we're at, if that is a directory, then add those words. But if fold is not a directory, then we could go ahead and make it. We could call this makeDirs function. And we could type in a whole long file path to where we want, or with it relative, we can go down relatively. We can't go back up relative. So if it's going to be in that delete folder, it's like another subfolder, we can just type the name there and what to call it in makeDirs, and then write. I guess it would have been better to do this the other way. It would probably make more sense logically, less back and forth, if I put the if statement out here. If is directory fold, from where we're at, if there's a directory called fold, well, I guess I need to say where that, say the whole thing in there. So C:/users, Chris, documents, delete, fold. So just check and see if that is a directory. And if it is, then we write it. But if it's not, then we want to call make directories and create those folders before we write it. I guess an even simpler, I didn't think this through a whole lot in advance. An even simpler thing would have been if not is directory, then make it, and then afterwards, whatever the result on that if statement was, write the file. But hopefully the logic, y'all are familiar with that by now. There's more than one way to do these things. I often run into that problem when I'm programming, is I'll keep changing my mind on the way through. Usually by the end, I feel like I have a pretty good idea. So no error message that time. Even though the folder didn't exist, it went ahead and created it. And we could use relative addressing to look down from where we're at, check our current address, and then go down. But if we're going to check directories, it's better to go ahead and put the whole thing in, which seems like a lot, but usually we'll have that stored to a variable. If we're going to be doing a lot of it, we'll have the directory paths we need stored in different variables so that we can get those. But that was something we didn't really talk about earlier, is making folders, and that can be a big deal. Making the folders, checking to see what's in the folder, looking to see if the file we want is there, get a list of everything in that directory, and then just kind of if there's a folder, recursively call and keep looking through all of the directories until we get a list of every file in a whole big chain of folders, kind of like this. Keep calling it recursively until we get a list of all of the files to see if the file we want is actually there somewhere on the computer. Checking that is directory, is file. Usually we don't need, just pick one or the other, because if it's not a directory, it's a file. If it's not a file, it's a directory. So that either one fits nicely into that. Join can be useful to build up the paths. Just keep adding different structures to it. And base name returns the very last thing on the path, which is often the one we want to deal with. Right? We have that big long file path of how to get to it, but we don't want to type that every time. Or if that's going to be in a return statement that we're going to check, we don't want to check we don't want to check that whole file path for just that last word. So we can just return the base name out of it. And one other thing, so I couldn't really think of a good place to put this in, so I'm just going to make it as a note. Well, actually, yeah, I think I could do this here. So if I save this, from where this is at, it's in the delete folder. So if I wanted to import something else that was in the same folder, that's no problem. I could just say import it. If I wanted to import something that's I'll write it here. So if I wanted to import something in the same folder, I could just say import other, whatever the other.py file is, and then use the stuff out of that. That's kind of what we did with the object-oriented thing, and some on when we were talking about functions. It just had the files of functions and would import them somewhere else to use them. Put them in the same directory, we can just ask for them. If it was in this folder here, we can go down a directory. Going down a directory is no trouble. So we could say from fold.other. And then that would know to look from the directory we're at, look into that fold folder, and then look for the other.py file. But going down is no problem, but going back up is a problem. So we can't really go back up so easily. So if there was another script in here, let's say, so let me create a new one, file, new one. And I wanted to import that last one. What did I call it? Was it example? Yeah, have that thing called example. So I'm going to import it and call that module here as just, sort of a main module to run that stuff. Call example.example with a path C:/, whoops, that needs to be a directory. 1/users. There's documents. Delete. Yeah, I'll just use that folder. Can't remember what it's doing right now. It's probably going to create. I should double check and make. Oh, not that one. Oh, that's the shell. One of these files. There it is. Yeah, I don't need to write another file. I'm going to call that and get the list of everything that's in that folder. Maybe I want a list of that folder. I'll go back to this first example guide. Whoops. My little laptop mouse pad is greasy because I didn't wash my hands earlier before using it, and then it got dirty, so I need to clean it now. Made it hard to. So I'll go back to where it just checks what's in that folder. So the example thing just gives us, if we're looking at a folder, it's going to return a list of everything in that folder. Back to that. So if we wanted to import that and use it, well, if we're in the same folder, that's no trouble. But if we go down a directory, or if we need to go back up a directory to get to it, then it's a problem. So I'll just go ahead and save this in that little folder we created there at the end. So I'll put it down here so that we have to go back up to get to that other folder. I don't know, other.py. I'm not feeling very creative about names tonight. So this one would give a problem when we tried to run this. If I hit function F5, no module named example. It can look down folders, but we do have to explicitly say, put the dot in there to say what folders to look into. It can look in the same folder, but it can't look back up. So to look back up, we have to specifically tell it where to look for the module. And this is important because whenever we write stuff, it's probably not going, our programs probably aren't going to be in that place where Python, the core Python library is, where it normally knows to look. So we can add stuff to that. So one of the libraries that is there is this thing sys, S-Y-S, for system. And let me comment these lines out for a second and show some things on sys. So like print sys.path. One of the things on the system is the path. And that's basically where is Python looking for folders at. So first thing is the folder it's in. But the first place it looks is to see if the script that's being imported is in the same folder as it. If it's not there, then it's going to go look over at this library where idle's running, the library where idle is stored, to see if it's something about idle. If it's not there, it's going to look over just at the library in general. Then it goes back up and looks at the language itself. Then it goes back up and looks at the zip file that this language was installed from, just to make sure. But the key thing is it's a list, right? And we see the square brackets, so we know that's a list, which we know how to add and take things out of the list. In particular, add things. We know where this other thing is. So we could just add it to the list. And which would be dot append, puts it at the end of the list. But it doesn't need to be at the end of the list. We don't need to check all those other places. So we could put it at the beginning. I can't remember, did we see insert? I don't think we did. So along with append, we also have a method called insert. And that puts, instead of tacking a new item on at the end of the list, we can stick it at any point in that list. I usually put it at number 1, which is their second. Remember, that's our second item on the list. So at index number 1, I'm going to put a new thing. Look and see documents. Oh, whoops. There's a whole bunch of stuff after. Actually, I already have it typed here. I'm going to look at all this stuff. I'm looking at the delete folder, and then it will search recursively through the folders. So every subfolder in delete, it will also look through, trying to find this thing, anything we want to import. Any Python modules, that's a way to say to look for it. So when we write our scripts, if they're not all in the same place we're running from, you'll want to include this line. So import the system, then from the attribute path in system, so sys.path, which is just a list of places it's going to look for Python scripts, for Python modules to import. We'll insert a new one. And if you know exactly where it is, you can put it near the beginning. Obviously, 0 is going to be the first place it looks. But yeah, I don't really have a good reason for going with number 1. I always put that as number 1. Because the first place it looks is the folder we're in. I guess that's a good reason. You want to look there first. But we'll push everything after number 1 back a little and squeeze this other address in so that we're going to look in this folder as well for this module to import. So now when I run that, we found the module and looked through and figured out, checked to see everything that was imported there. And then PyCache, I don't think we talked about this. Oh, well, we can see file type right here. I was going to pull up the properties list. You can see the type. It has the same name as what we had, example dot, only instead of example.py, it's cpython-37, which is a compiled Python file. So instead of interpreting it, it went ahead and compiled that so that it'll run quicker, and we can just directly pull everything from the module a whole lot quicker. You've probably seen that folder show up somewhere. But that's, wherever we store our scripts, it's probably not the core place to look for the library. And a lot of times when we need to use them, it might not be the folder we're working in directly. So if we want to, that's how we say where to look otherwise. So import system and just insert it into the path we're looking at. And every language has this. Visual Basic has this. We looked at PowerShell. PowerShell has this. It's just Python is definitely the easiest language to work in. That's the reason it's by far so much more popular than any other programming language. And most of this semester was spent on Python, so I thought I'd show it here in Python. And that other thing we did, this. So these are some very useful methods. So from the OS library, we can make directories, because we could write files to the same directory we're in, but we couldn't create new directories. Or get a list of everything that's in a directory. That can be incredibly useful sometimes, because once you have a list, then you can go through that list and just work with the stuff that way. Then this nice little Boolean to check if something is a file or a directory. And then this method base name to pull off the very last thing on a big long file path directory structure. Because often that's all we want is the name of the very last thing on that directory structure. We don't want all the stuff to get there. It's just the computer needs all that stuff in order to find it. When we're actually working with it, we just want the last bit. And join can be really useful. Personally, I prefer to concatenate it. I don't know if there's a good reason other than personal style. I think from copy and pasting, I find it easier to delete sections from concatenation than delete pieces of a method. But that would be more efficient than string concatenation. So those were just a couple things I wanted to go over because we did a very quick pass at the file in out, the file IO. And that is a critical point of software. If we're making an application, we're doing that for a reason, which means we want our data to stick around, and we want to be able to work with our data, which means the folders and files associated with it. Or another way I like to put it is, I always start off with this when I'm making a piece of software and do this, all the files and folder stuff first, because if there's no place for things to go, then there's no way for things to fall in place as it comes together. That's the way I like to think about it. We got to have a place for the stuff to go in order for things to fall in place as we make it. So those are just some useful methods I thought I would share with you, because we looked at the very, very basic file structure, and I'm not sure how much further y'all are going with programming. Some of y'all might have a lot of software development classes still ahead of you, or computer science classes ahead, and some of you, this may be the last class you have on programming. So I wanted to make sure and mention those, because those are very important, and we passed by it very quickly. Any questions about that?
Nope.
A very useful thing, and just like on that video at the beginning, near the beginning of the semester somewhere, about running Python on the Apache server, which would be very similar to run it on a Windows server or whatever type of server you're on. Those Python will recognize what system it's running on, and those same methods will work there in a server. So it's very nice for server management as well. Makes your printer server management into reusable Python scripts, which can be very time saving, I guess, for repetitive tasks. But that was the only thing on my list, because we passed the last thing I wanted to talk about, because we passed over it so quickly in the file in out section from the statewide module. I guess that's it for the semester, unless anybody had any other questions.
No, not I can think of.
All right, well, y'all have a great holiday, and remember, get everything turned in by Saturday. If you have any questions, let me know. If you need anything open back up, just let me know. I can open any closed quizzes or whatever, just if you want a few extra points, grab those few extra points that are missing. Just shoot me an email before Saturday at midnight. Well, really before Saturday at like 10 o'clock. I go to bed early too. But otherwise, everybody have a great holiday.
You too. Hopefully see you in another class. I probably will see you in another class. I like probably do another programming class anyway. So
I look forward to it. Yeah, there's some interesting stuff. It seems like we covered a lot, but there's still so much more that can be that we can talk about in programming. Things that make it easier and stuff.
Okay. Yeah. And then hopefully we won't have to deal with COVID anymore, so we can actually be in class.
Yes. Classrooms are nice.
Yeah, definitely help for sure. There's a lot of distraction at home.
Yeah. It's and seeing each other, seeing faces while we're talking, and it makes a big difference giving lectures. That's for sure.
Yeah, it does. Well, all right. And in that case, enjoy your holiday. I'll see you, whenever the next class is.
All right. See ya.
See you.
Take it easy.